suggestion: twin paradox, the moment relativity collapses, rotational twin experiment. Subtitle: Relativity explain this. Even kids know why. Cut 1, title card, music. Narration. You've probably heard of the twin paradox, a thought experiment designed to expose the contradictions in Einstein's theory of relativity. In it, one twin stays on Earth while the other travels at near light speed in a spaceship. Modern physics teaches that the traveling twin ages more slowly due to time dilation. But is this really the truth? Main point 1, exposing the flawed interpretation. Cut 2, animation, spaceship launching, turning, and returning, with acceleration marks. Narration. Physicists often argue that the traveling twin experiences 4 phases of acceleration, so the situation is asymmetric. They claim this explains why the traveling twin ends up younger. But wait, isn't special relativity based on the principle of symmetry? Why bring in general relativity to patch up this contradiction? This isn't logical, it's just shifting the problem to another theory. In real science, evidence and reasoning should matter more than academic consensus. So let's test relativity with a truly symmetric experiment. Main point 2, a new thought experiment, the rotational twins. Cut 3, animation, 2 planets orbiting a sun in opposite directions. Narration. We present to you the rotational twin experiment. Let's walk through this slowly. Imagine planet A orbiting the sun clockwise at a constant radius and speed, uniform circular motion. Now create planet B with exactly the same orbit, same radius, same speed, but orbiting counterclockwise, perfectly symmetric. Now place twin A on planet A and twin B on planet B. They start at the same time, travel in opposite directions, and meet again after one full orbit. Now here's the key question. Which twin is older? Main point 3, relativity silence. Cut 4, animation freezes, big question mark appears. Narration. In this perfectly symmetric setup, there is no preferred frame. Special relativity says all inertial frames are equal, so time shouldn't pass differently for either twin. But in reality, they reunite and compare clocks. If there's a time difference, it implies an absolute time must exist. Yet relativity explicitly denies such a thing. So how do physicists respond? Some say, but circular motion means acceleration. It's not inertial. Fine, but in this experiment, both twins have identical circular motion. Same radius, same speed, same acceleration, only the direction is different. Thus, all effects cancel out. We're left with pure symmetry. And yet, relativity still can't predict a result. Main point 4, common sense exposes the flaw. Cut 5, classroom animation, have chalkboard drawing of orbit paths. Narration. This experiment doesn't require complex math. Even a child would say, if they moved the same distance at the same speed and met again, their time should be the same. But relativity says, no, it depends on who's observing. Then we must ask, can observation override reality? If 2 clocks meet, their readings should reflect real time, not just perception. ChatGPT's logical and objective evaluation. Cut 6, animated book opens, phrases highlighted. Narration. The rotational twin experiment exposes a fundamental flaw in relativity. When all variables are symmetric, speed, path, acceleration, but the theory still fails to explain who aged more, we must admit, it doesn't describe physical reality. It describes interpretations, not causes. This is not just a thought experiment. It's a mirror reflecting relativity's core inability to handle symmetry. And when even children can see through the flaw, you know it's time for physics to be re-examined.